Good morning everybody. In this video we will see some basic definitions of magnetism. Um, from your school level you would have studied what is magnetism and earth is a magnet and what are the lines of forces and how the magnets are taken and what are the properties of a magnet and you know about the north and south poles of a magnet, and when heating magnetism is destroyed. So all these points you know about magnetism. These are the basic concepts, and our syllabus is ferromagnetism, but you should know some basic definitions in magnetism. So these are the basic definitions. We'll see one by one. First one is magnetic field. So wherever the when you place a north pole, a unit north pole at a point, if it experiences some force of attraction or force of repulsion, Coulombic force, then we can say then there exists a field. So a field is a space surrounding the magnet where the north pole experiences a force. So that is called as the magnetic field. And the magnetic field strength is the intensity. Magnetic field intensity or magnetic field strength is the magnitude of the force experienced by a unit north pole placed at that point. And next is the dipole. Dipoles are two dissimilar charges, or here in magnetism two opposite poles, north and south pole. North and south pole separated by a very small distance is called as a dipole. Okay, so dipoles are two dissimilar poles of pole strength, let it be m, separated by a small distance. They constitute a dipole, and dipole moment is nothing but the dipole moment mu is equal to one of the pole strength into the distance between the two poles. So the dipole moment is nothing but the product of dipole into pole strength into distance between them. And coming to torque, torque is um, the um, the turning effect of a couple is called as the torque. So the force which is responsible to turn something is called as torque. So that torque is equal to mu into B, where B is the magnetic induction. Magnetic induction is nothing but the force experienced or the magnetic field strength, okay, inside the material. So then it is called as B. If it is the external applied field, then it is called as H. Okay. So H is the externally applied field and B is the magnetic induction, B. Next is the lines of forces. Next is magnetization. Magnetization is the magnetic moment per unit volume felt inside the magnetic material. Coming to the magnetic material, you should know the magnetic material naturally available is ferrous, nickel and cobalt and some of the rare earth elements. I will post a question that you have to tell me why only these three elements, ferrous, nickel and cobalt, are magnetic materials. You find the reason and WhatsApp me. Okay. Anyway, I will tell you the reason in my next video. Coming to magnetization, M. Okay. B is the induction, H is the externally applied field, and M is the magnetization, M. Okay. And coming to before that susceptibility, permeability. Permeability mu is equal to permeability mu naught in free space is 4 pi into 10 to the power minus 7 Henry per meter. And actually permeability is nothing but it is a measure of how easily we can magnetize a material. So this number says that how easily a material can be magnetized, how easily the flux lines enters inside the magnetic material. Coming to the flux lines are nothing but lines of forces. So if you take a magnetic needle and keep it in your north pole of a magnet, so the needle will point in the opposite direction. So because of the north repulsion, so if you place in that point, you can draw lines of forces. It will run from north to south. So the lines of forces are the lines running from north pole to the south pole. So the number of lines per unit area is called as the flux. Flux phi, magnetic flux density, is nothing but the magnetic lines of forces per unit area. Okay, so this is also a measure of the magnetic induction B. And so this is a number which tells you how easily a material can be magnetized. And this is the permeability of free space and permeability of a medium M, and the relative permeability is nothing but the ratio between the permeability of the medium by permeability of the free space, and this has no unit. Coming to susceptibility, susceptibility chi is nothing but it is a measure of magnetization happening inside the material per unit applied external field. So you apply a field and you magnetize the material. We will coming to the point what is called as magnetization happening inside the material. So if it is outside the material, H and B, and if it is happening inside the material, so something has happening inside the material, no, we will see what is happening in ferromagnetic material. And coming to Bohr magneton, so there is a property called Bohr magneton. It is a parameter. It is B is equal to EH by 4 pi m, and and the unit is ampere meter square. So this Bohr magneton comes because each atoms, each molecules will have magnetic moment because of the revolving electrons. Electrons have orbital magnetic moment and spin magnetic moment. Putting together, they have a magnetic moment. So this magnetic moment per unit volume is the Bohr magneton, and it is a measure of EH by 4 pi m, and where E is the charge of an electron, it is 1.6 into 10 to the power minus 19, and H is the Planck's constant, 6.6266 into 10 to the power minus 34 by 4 pi into mass of the electron, it is 9.1 into 10 to the power minus 31, and the Bohr magneton is 9.27 into 10 to the power minus 24 ampere meter square. So this is the measure of the magnetic moment happening in an atom in atomic order. And so we have covered all these points, all these definitions you should know before going to ferromagnetism. Thank you.